Hi. Hi. Today's topic is phytochemistry, which involves tannins, a class of phytoconstituents, tannins. As you can see on the slide, tannins can be seen in all these type of fruits. This is amla, very rich source of tannins. Green tea. Tannins are basically a class of chemicals which are responsible for tanning of the leather, and they actually prevent putrefaction of hide or putrefaction of proteins and convert animal hide into leather. And such process of converting hide into leather is also called as tanning process. Recently, tannins have been defined as the derivatives of polyhydroxy benzoic acids, which are capable of combining with proteins to prevent their degradation, what we generally call as putrefaction. These are some kind of tannins: gallic acid, benzoic acid, then ellagic acid. These are all tannins. In plants, it's a large group of complex substances and distributed almost in every part of the plant, such as leaves, fruits, bark and stem, and protection of the plant during certain stages of growth, destroyed or deposited as end products. They are accumulated in plants, and you can find them in bark of cinnamon, cinchona, acacia, pomegranate, roots and rhizomes like fern, leaves of tea, especially green tea and eucalyptus. Then you can see them in seeds like coca, then cola seed or cola nut rather, areca nut. Then flowers like or flower buds like clove, red rose petals, and myrobilans, that is Terminalia cebula, Terminalia bellerica, and pomegranate rind. Extraction process is quite simple in case of tannins, because tannins are thermostable products. Depending upon various sources, you can select the solvent such as ether, methanol, acetone, ethyl acetate, as well as water. The clear extract is obtained, and which is actually dried under vacuum to get pure tannins. Now, tannins are classified as hydrolyzable tannins, condensed tannins, and pseudotannins. Pseudotannins are not considered as tannins, but they give many tests or many chemical tests which are applied for tannins. Hydrolyzable tannins or pyrogallotannins, they are readily hydrolyzed by acids or enzymes such as tannins. They are formed from several molecules of phenolic acids such as gallic acid and ellagic acids. These are some of the tests which are performed for hydrolyzable tannins, and they give certain color, typical color, blue color with FeCl3. Next group of tannins is condensed tannins or pyrocatechols or phlobatannins. These includes all other true tannins. Then they yield catechol as the end product of the dry distillation. Therefore they are called as catechol tannins. And condensed tannins also give chemical test with certain chemicals, especially FeCl3 gives green color, and examples are cinnamon, cinchona, acacia, areca seed, green tea, etc. The last group of tannins, what is called as pseudotannins, they are compounds of low molecular weight as compared to true tannins. They do not tan leather, that is why they are not considered as tannins. And with FeCl3 they do not give blue or green color, instead they give purple to violet color. And examples are catechu, then chlorogenic acid from coffee, mostly unroasted coffee, and nux vomica seeds. Properties of tannins are they are amorphous, they do not crystallize and form colloidal solution with water. They are soluble in dilute alkali, alcohol, acetone, and in many such organic solvents. And they have very sharp astringent test, and with ferric acid they give color, as I already said. They precipitate proteins and they prevent proteins from putrefaction. Use of tannins, they are mostly used as antiseptic in inflammation and piles, burns, etc., and also as during gastrointestinal diseases like diarrhea, and on prolonged use they may prove to be carcinogenic. So there is a need to use them with proper care. Thank you so much for patient listening.